Alright, so let's take a look at the aldehydes. So aldehydes can be identified through the functional group of the carbonyl group, so the double bond O, and the H. They're always terminal, so that means at the end of a chain. Because of the one H, they can be further oxidized. So we can test if we have an aldehyde in two ways. The first test we can do is the acidified dichromate test. So because of this hydrogen or the terminal hydrogen, if we have an aldehyde, we can get a positive test, so from the orange to the green. We can also test it with Tollens reagent, and Tollens reagent will form a silver mirror on the inside of our test tube, and that will indicate the presence of an aldehyde. So let's have a look at how the Tollens reagent works. So when we add Tollens reagent to an aldehyde, we, similarly to acidified dichromate, oxidize this aldehyde to a carboxylic acid. So we get this oxidation. But because we are not in acidic conditions, we end up having a carboxylate ion rather than a carboxylic acid. So because we get the carboxylate ion, we're also reducing then the silver ions. So our silver ions in the Tollens reagent gain electrons and form a silver precipitate. This silver precipitate is what we see. So that's how we see the silver mirror forming. With our aldehyde, because it can be further oxidized, it can actually be further oxidized to a carboxylic acid. So if we take a look here, our carboxylic acid that we would get in this case is ethanoic acid, because it's going from ethanol to ethanoic acid. If we allow things, so if we had the acidified dichromate, we would actually get our primary alcohol converting twice. So we'd get that first conversion to an aldehyde and secondly to the carboxylic acid. So if we want to isolate an aldehyde, we need to use a special technique. Alright, so this is an example of propanol getting oxidized to propanol, and if we want to isolate the propanol, we can see here we've got this dropping funnel. So in this dropping funnel we have the dichromate, sometimes potassium, this time we've got sodium dichromate, water and ethanol. Now, if we were making propanol, we'd have propan-1-ol. So the important part is that it's the primary alcohol. If it was a secondary alcohol, we wouldn't need to go to this trouble because it can only be oxidized once, as we can see underneath, and that would form the ketone. In our dropping funnel, we will add in our alcohol, and we've got our acid in the pear-shaped flask. Now that's because it's with acidified dichromate that we get the oxidation occurring. So what we'll do is reflux it, partly to speed up the reaction, and the other reason being that we want to be able to boil the aldehyde as it's being produced. So as soon as it's being produced, we want to then condense it out and collect it. And because of the physical properties, so if we take a look at the alcohol versus the aldehyde versus the carboxylic acid, we can see here that we've only got dipole-dipole bonding within the propanol. The propanol's got hydrogen bonding, and the propanoic acid has hydrogen bonding, but also it has this additional polar group, so that'll make its secondary interactions stronger. And so the propanol is going to have the lowest boiling point out of the three of those. So as it's formed, it's going to be the one that's boiled off first, and therefore we're going to be pretty confident that that's what we're collecting if we don't let the temperature get too high. And just a reminder then that our confirmation test, if we have an aldehyde, we will get this colour change occurring from orange to green with the acidified dichromate, but we can also confirm that we have an aldehyde with the silver mirror test. So the silver mirror test is only for aldehydes, whereas the acidified dichromate, it could be an alcohol or it could be an aldehyde. And a little recap on naming our aldehydes. Well, they're made from primary alcohol, so they're always at the end of a chain. And we name them with al at the end. So we look for the length of the chain, and then the aldehyde group we identify it and call it al. So in this case, ethanol.